Integration trig type 2 formulas. So as I've seen already, we can't integrate a product or a quotient. So in the following questions that we're looking at here with our trig, we're going to be given a product or a power of cos or sine, so like sine squared or cos squared to integrate. So we have to use our formulas in our maths tables before we can actually integrate. So our formulas are page 14 and 15 in our maths tables. And you can see here the ones that we're going to be really looking at are going to be our cos squared and our sine squared, and also our product. So we'll have to change our product back into a sum before we can integrate. So these are the main ones that we will use in these questions. So in our first example here, we're asked to integrate 2 sine 6x cos 2x dx. So really what we have is sine multiplied by cos. So we have to go to our maths tables and see which formula can we identify. And in order to do that, the best way is to write the angle A over 6x and the angle B over 2x. And then I can write out that formula is 2 sine A cos B. And if I look at my maths tables, page 15, I can clearly see that that is going to be 2 sine A cos B. So it's going to be this one here if I underline it. So that is equal to sine A plus B plus sine A minus B. So in other words, wherever there's an A, we're going to put 6x, and wherever there's a B, we're going to put 2x. So this can basically be written now as, not 2, but sine A plus B, so that's 6x plus 2x, plus sine A minus B, so that's 6x minus 2x, and that's dx. So if I simplify before integrating, I'm going to be integrating sine 8x plus sine 4x dx. Let's put brackets in there. Okay, so if I integrate sine, well, we can go to page 26 in our maths tables, because again, we're looking at integration. And if I integrate sine, I get minus cos. So it's minus cos 8x. But of course, I have to divide by the derivative of this 8x. So the derivative of 8x is 8. So it's minus cos 8x over 8. And again, if I integrate sine, I get minus cos 4x. But again, I have to divide by the derivative of this 4x, which is, of course, 4. And because there's no limits here, we always have to have our constant of integration in our answer. So if we look at our second example here, we have cos 2x, cos 5x. So again, I'm going to put A over the angle 2 and B over the angle 5. So if I write that out, that's cos A, cos B. Now, if I go back to the previous page and look at my tables, and let me just erase the last one we used. So if we're looking for cos A, cos B, I can't see any cos A, cos B, but I can see a 2 cos A, cos B. And 2 cos A, cos B is equal to cos of A plus B plus cos of A minus B. So that's the closest thing we can get here. So what I have to write down is we have 2 cos A, cos B, and that's equal to cos of A plus B plus cos of A minus B. But I want cos A, cos B, so that means I'll need to divide both sides across by 2. So that's cos A, cos B is equal to, and rather than dividing everything by 2 on the right hand side, I'm just going to say multiplied by a half. So that's the same as dividing by 2. So that's a half times cos of A plus B plus cos of A minus B. Okay, so if I put that into my formula then here, we're integrating cos 2x, cos 5x. So we know that's going to become a half times cos of A plus B. So that's 2x plus 5x plus cos of A minus B, which is cos 2x minus 5x. and that's dx. So simplifying that, that gives me a half times cos 2x and 5x is 7x, plus a half cos 2x minus 5x is minus 3x. And that's all integrating with respect to x. So we have a slight issue here because we have a cos of minus 3x. So what we can do is we can actually change that. And again, we can go to our maths tables. And if we look at page 13 there, we can see that if we have cos of minus a, that's the same as cos of a. So cos of a negative angle is the same as cos of the positive angle. But sine of a negative angle and tan of a negative angle is actually minus sine a or minus tan a. So therefore I can rewrite this as a half cos 7x, and then it's going to be plus a half cos 3x. Okay, so now we have separated everything out into something that can be integrated. We're ready to integrate. So again, if we go to page 25 of our maths table, or 26 of our maths tables, I should say, sorry, and we will look at cos. Well, if we integrate cos, we get sine. So it's going to be a half, and if I integrate cos, I get sine 7x. But of course, I have to divide by the derivative of sine x, which is 7. And then plus a half, and then it's times. Integrating cos, I get sine 3x. And then dividing by the derivative of 3x, we get divided by 3. And again, no limits, so we must put in plus c into our answer. So one last thing to do is just tidy up. So we have a half times sine 7x over 7. So therefore that's going to be sine 7x over 14. And then a half times sine 3x over 3 is sine 3x over 6. And then that's plus c. So that is our answer. So one last example then. So in this example here, we have to integrate cos squared theta d theta. So again, I'm going to put a over my angle. And if I go, what does that formula look like? Well, that would be cos squared a. So we need to go to our tables and see, can we find the formula that is linked to cos squared a? That's going to give me something that I can integrate. So we can see here on page 14 in our maths tables, cos squared a is equal to a half times 1 plus cos 2a. And therefore we can integrate that very easily. So let's apply this then to our 3 theta. So what we have to do then is wherever there's an a, we're going to be putting 3 theta. So that's going to become the integral of a half times 1 plus cos 2a, and a is 3 theta. And we're integrating that with respect to theta. So therefore, if I just tidy up before we integrate, that's going to be a half times 1, which is just a half, plus a half times cos 6 theta d theta. So if we integrate a half with respect to d theta, then that's going to become a half theta. And if we integrate a half cos 6 theta, well again, if we're going to page 26 in our maths tables, we can see that when we integrate cos, we get sine. So that's going to be a half times sine 6 theta. And again, I must divide then by the derivative of 6 theta, which is of course 6. And then there's no limits, so I must put in plus c. So therefore that can be written as a half times theta, or theta over 2, plus sine 6 theta, and 2 times 6 then is 12, plus c. Okay? So it's really about identifying which is the correct formula to use, and the easiest way to do that is to always write a or b over the angle. So if there's 2 angles in the integral, put a and b over them. If there's 1 angle, just put a over it, and then refer to page 14 or 15 in your maths tables to help you integrate. So I've uploaded a sheet onto Teams with, there's 11 questions. So what you're going to do for me is you're going to do question 1 to 9 on the sheet, because 10 and 11 have what we call limits, and that's what we're going to be looking at tomorrow. So you're just focusing on 1 to 9. And then what I will do is later tonight, after you've done the questions, I will upload the solutions so you can check your homework. So you please tick off the ones that you've gotten correct, and any of them that you haven't got correct, just send me a message and then I'll upload a video of the worked out solution talking you through it if there's any issues. Okay?